Hello everyone, this is Finn from Robotics in a Nutshell, and today we'll talk about how to bridge custom messages between ROS1 and ROS2. So currently I'm here in this empty folder, and I will use this folder to create three workspaces, one for ROS1, one for ROS2, and then another one for the bridge between ROS1 and ROS2. So I will create three folders, one for each workspace. And in each of these workspaces I will create a source folder as well. In order to bridge custom messages, of course, we need custom messages. So I will create a package in ROS1 and in ROS2, and in each of these I will define a custom message and then also write the code in order so that building the workspace and the package will then generate the messages for me. I will start with the ROS1 workspace here. Be sure to source your ROS installation and also make sure that you don't have any ROS installation sourced in your bash RC. This could lead to conflicts. So I will create the package here and then I will add a message folder and put in the custom message file here, and then I'll continue to add these lines here to the CMake list and the package.xml, so that building the workspace will generate the messages for me. Now, to confirm that our message generation was successful, we can build the workspace, after that source it, and then we can use ROS message info and then our package and the message name, and it should then print out the definition of our message and we know that it's successful. Now I will not jump into the ROS2 workspace immediately now. First I'll add the talker node that will publish our custom message continuously inside this ROS1 workspace. This node we will use later. So you've just seen me copy the code here. I'm not going to explain how it works because this would be out of the scope of this tutorial. After this I have to adjust the CMake list file so that ROS will build this talker node. Then I can build my workspace again, and here I attempt to start it immediately. I forgot that I have to start the ROS core. And then we can start the talker node here, and then we can open a new terminal, and we have to source our workspace here again because we use a custom message. And then we can use ROS topic echo to see that the talker node is working as expected. If you're wondering what this SDS command was that I just typed in the terminal, that's actually just an alias, and it just does source devel setup.bash. So I will do the same now for the ROS2 workspace. I will create the package, and then I will create the custom message. I will adjust the CMake lists file, and also I will create the talker and listener node immediately. So I will add two CPP files here in the source folder, one for each node, and add the code again. And then I also have to adjust the CMake list to add the executable. And then here's a tip that I can give you that cost me quite a lot of time. So if you have in ROS2 a node that resides in the same package as the message definition itself, then you have to add this line here for each executable in your CMake list.txt, otherwise it won't work. At this point I attempted to build the workspace, but I forgot that I still have some things missing in the package.xml. So you have to add these lines here so that the message generation for ROS2 works. And then I tried to build it again, and this time it worked. But when I tried to start the talker node, it told me that it can't find the executable, and this is because I forgot to tell CMake to install the nodes, and I also adjusted that and built again, and after that I could run the talker node successfully. You can also see here that starting the listener node works also as expected, but what doesn't work is that if I start the talker node here, and I also again don't forget to start the ROS core, it will not transmit the messages from ROS1 to ROS2. As you can see, the listener is not receiving any data, and this is what we will fix now. And for that we will use the ROS1 bridge package for ROS2. So let me go into my bridge workspace now, into the source folder, And then I'll get the repository, so I'll just clone it. The link for the ROS bridge you will find in the description. And yeah, after that, once we have cloned it, we will have to make some adjustments. And that is if we have a different package name, or if we have different message names or different field names inside the messages between ROS1 and 2, but we still want to map these. So for example, in this case here, I have a package in ROS1 that's called custom message ROS1, and then in ROS2 it's called custom message ROS2. And since these are different, we need a mapping. And this is also true if you have different message name or message field, as I said before. And to get this mapping to run, you have to create a YAML file. And you create this YAML file inside your ROS2 workspace, in the root of the workspace. And in there you can define the mapping. And in the documentation of the ROS bridge, you can find quite a good explanation how to do complex mappings. I will just explain how to do a package mapping here. So you have to write this dash symbol first, and then line break, and then you have to indent it. I guess this is to be conform with the YAML format. And then you define the package name of your ROS1 workspace and then the one of your ROS2 workspace. And like that, the bridge knows how to pair these two messages together. As usual, you also have to adjust the cmakelist.txt and the package.xml. So in the cmakelist, you have to install the YAML file that you've just created. Otherwise, it will be missing in the install folder. And then in the package.xml, you have to export these rules as well. You do this with this open bracket ROS1 bridge mapping rules equals and then the name of your YAML file. And you do all of this in the ROS2 package. And now comes another interesting part. Before we can build the bridge, we have to do quite a lot of sourcing. So we have to source our ROS1 installation, we have to source our ROS2 installation, and we also have to source any workspace that contains our custom message definitions. So we also have to source our ROS1 workspace and our ROS2 workspace. And only after that can we build. And to build, we go into the bridge workspace, and then we type this colcon build -- symlink install. This is probably not required, but it's recommended. And then also this cmake force configure. Then we can hit enter, and now it will build. And this will take quite some time. For me, it took approximately 7 minutes. Can also take longer or shorter. And yeah, I'll see you then. Okay, the bridge has compiled now. The next step that you have to do is to source the bridge workspace, and do not forget this step. It can lead to a lot of headaches if you forget it. And after that, we can run this command here, ros2 run, and then ros1 bridge, dynamic bridge, and then -- print -pairs. And this will print all the available mappings for the bridge. And we could now scroll through this and search for a message, but instead I will just pipe it into grep and then just search for the string custom. The I just means ignore case. And you can see now that we don't get any result. And this surprised me as well. And I went on a little search to find out what it is. And it turns out that I forgot to build my ROS2 workspace again after I told the cmake list there to install my mapping file, the YAML file, and because of that there was no YAML file inside the install folder, and this then led to the ROS bridge not implementing and building the mappings. So after I built my ROS2 workspace again and build the bridge again, and I can only tell you delete the build, install and log folder and then build again. I know it takes long, but it's worth it. This way you make sure that this is not the cause for your messages not being built. So after building the bridge workspace again, we source it again, and then we can run our command again, and this time you can see that we can actually find our mapping and everything is good. The last thing that remains now is to show that it actually works. And then one thing that you also have to do is to export your ROS master URI in the terminal that you will use for the bridge. So do export ROS master URI and then just give your address for the localhost, except if you have your ROS core somewhere else. I will start the ROS core here, and yeah, then I will start the ROS bridge, and after that the ros1 talker node. Of course, first I always have to source my workspaces, and then I will start the listener in ros2, and as you can see, the listener successfully receives the messages. And I can also do it the other way around, so I can start a talker node here in ros2, and then to switch it up I can also do a ROS topic echo, and you can see that I also receive the messages in ros1 from the ros2 talker. And yeah, just be aware that a ROS topic list might not work, so in order for the bridging to happen, there has to be a publisher and a subscriber, and the ROS topic echo implicitly creates a subscriber, so just be aware of that. And yeah, I know this was quite a lot of information, and it was in a quite quick fashion. You can always stop the video in between and have a look, but also I created a repository as an example. You can find the link to it in the description, and there you can find like a long readme where I wrote everything down and I gave some examples, and you can just download the repo, build it, and test it out for yourself. So yeah, thanks for watching, and see you in the next video.